Hi, I'm Carl Loveridge, and I am from Extra Cheesy Games, and today I would like to begin my first lecture on how to make shaders. This is going to be an introduction, and frankly, what happened was I was wanting to just dive right in and start explaining more complicated shaders, but I felt like as I was explaining those shaders that if you didn't have a basic foundation of understanding that a lot of what I was saying might be a little bit discouraging. So what this is meant to be is this first one is to introduce some basic concepts about shaders. And so I want to go ahead and dive in and go through some anatomy of a shader and give you some other information. So first of all, let's talk about why do you need to make shaders in the first place. I mean, Unity, I'm using Unity as my development engine. It comes shipped with lots of shaders, and I think you might look at all those shaders and say, well, I don't need to make a shader because it's got so much. Well, the fact is, Unity ships with its target audience being everything from a mobile simple device all the way up to high-end consoles like your PS4, your Xbox, and they don't know necessarily what your specific need is going to be. So there's a couple of reasons why I would give. I boil it down to just two reasons, frankly, why you need to make your own shaders sometimes. One is you need to customize something that they don't ship you in the box that you might particularly need. Here's an example of a shader, and I'm going to talk about this shader in another lesson. This vehicle here, this is my shader I've written. I wanted to be able to colorize the vehicle, where I could say, okay, I want to have some different tonality in here and do whatever I wanted to do to that vehicle. I wanted to have some reflectivity and some specularity. Well, that shader does not come shipped with Unity. Now, you could go out to the asset store and maybe find somebody that's done something like this for you. But honestly, if you want it done right or the way you want it, you're going to have to break it down and start to understand some of these things or hire a shader artist to help you. So that's one reason. And the second reason I think is most important is performance. Now, I have been doing games for about 20 years. My first machines I did games on were consoles for the like PS1, PS2, PS3, and those consoles were kind of, we actually wrote our own proprietary engine. But when we started to do mobile, we picked up Unity, and the fact is mobile does not have the capacity or the power that those higher end consoles do, like your PS4. So you're going to have to possibly go in there and make modifications to those shaders to make it run better, so that when you get a lot of content on the screen, that it will, you'll be able to run it without bringing the system to its knees. Okay, so that's the whys, and there's probably other reasons, but that's a good list. My strongest arguments for why you need to do it. So let's talk about the anatomy of a shader. A shader has interface in that's what you're going to edit. For example, in my shader here, the interface is down here in this thing called Mom's Van. There is a color, there's a couple of colors, there's some texture plugins, there's some variables that I can tweak. This is what when I talk about an interface, that's what I'm talking about. And from there, we have in Unity two types of shaders that you will get familiar with. The easiest type to get familiar with is what's called a surface shader. And the surface shader is Unity's, I believe they were introduced in Unity 5. It's Unity's attempt to take all the complex things like your lighting and all that and kind of hide those things and just let you write specific things to manipulate the pixels on the screen. Oftentimes you'll find yourself using surface shaders quite frequently. They're easy to use. They do a lot of the heavy lifting for you, but they also tend to be a little processor heavy when you're dealing with mobile. So that brings me to the second type of shaders that they have, and those are called your vertex fragment programs. These programs are closer to the metal of the kind of shader that communicates with the GPU. They don't do a lot of the heavy lifting for you. You're going to have to program that in yourself. And so just to kind of show you how you make those two kinds of shaders, let's go over into Unity. And I've got this lessons area. If you, the way I like to set my shaders up in my project is I will actually create a folder called shaders. And if I have subfolders, like if I have a group of shaders that are kind of similar, I will group them together. But for the sake of just discussing these two types of shaders, your surface and vertex fragment programs, let's just make a sample of each. So if you right click in your area where you're going to create a shader, you come down to shader, and I'm going to make a standard surface shader. And I'm going to call this, just give it a name, surface shader. Let's say surface shader lesson. And then I'm going to make a fragment program, vertex fragment program, and that is called shaders, and you just create an unlit shader. And I'm going to call this a VF shader lesson. And let's fire up both of these and compare them side by side. Now what I did is I just double clicked the shaders, and that fires up mono development where you can see it. Nice thing with the later versions of Unity, you can actually split these into two screens by right clicking on the tab and move it over. So let's compare these two, and before let's do this, let's actually go back into Unity and apply this to something. I'm going to start a new scene, create a just a 3D object that's a cube, and I'm going to make two of these cubes. Now, obviously, with shaders, you can't use those directly. I got to make a material first. That'll get used. I'm going to call this my surface mat. I'm going to duplicate that, and I'm going to call this my VF mat. And one thing is when you make a shader, I'm going to assume you have some knowledge with how to do these, but you click on here, and when you make a shader from scratch, Unity, you might wonder, well, where did this shader go? Let me give you a little hint. If you go over to your code that got generated, you'll see this top line here. This is kind of the path to where that shader is constructed. So Unity will put them into a folder called custom, and then this was the name that was assigned. And you can actually change these later. See, isn't this interesting? I called the surface shader a custom surface shader, but the unlit one, it actually called it unlit VF shader. So here's what I'm going to do. I'm going to make this a little easier. I'm going to call this lesson on both of these. I'm going to save them. I'm going to come back over here into Unity. I'm going to look at my surface the two materials I made. This is my surface one. I'm going to go down here, and there should be a folder here called lesson. And now there's my surface lesson shader. And then the same for this other one. I'm going to change this to lesson VF shader. And I'm going to assign the surface material to the cube on the left and the vertex fragment to one on the right. You immediately can see the difference in what happened here. The one that's the surface shader has got all this lighting working for us. If I move my light around, see, it's respecting it. And just to kind of give you the quick and dirty about what's going on here, you know, shaders are nothing more than color manipulators, okay? And lighting is really nothing more than intelligent light manipulation based on some light information. So what's happening inside of the shader isn't some magic voodoo. What is happening is there's math that is going on under the hood that's figuring out the direction of the light in comparison to the direction of the faces on the cube. and throwing out lighting information that is applied by color. And let's look at these shaders, and you'll notice the one on the right did not do anything because, as far as it's concerned, there's no such thing as a light in here. Let's compare the two shaders and just kind of see the differences. Now, the interface. Remember the anatomy of the shader. The interface for the shaders are described in this group called properties, and you'll notice they both have the same basic entry. The only difference is the Surface version has more stuff that it's doing. For example, I have a color, I've got my texture I'm reading, glossiness, and metallic. So when I come over and look at these guys, if I pick on this one, and I just roll down into here, there is parameters in here that I can tweak. That's the interface portion of that working there. In the other one, all I have access to currently is a texture, so I can't do anything in this one. If you look at its interface, it's very simple. All I have is access to is a texture, which I don't have one. If I went out and found something that like that, that's the best it'll give me. Now, the question might be, well then, if the Surface one does so many more interesting things than the one on the other, on the vertex fragment, why would I ever use the vertex fragment? Again, back to the 2 points. Everything you get in a shader costs something, and that's something that's very important to understand about shaders. The cost for doing lighting is a pretty high cost, especially on mobile. And so sometimes you don't need lighting. So if the right time to pick one version over the other is oftentimes dictated by performance. Now, let's move on. I'm going to keep this as layman and simple as possible. Let's go back to my lesson here. Let's talk a little bit about the way color is used inside of a shader. Now, in Photoshop, we often think of color in terms of 0 to 255 per channel. So your red, green, and blue can have 0 to 255. In a shader, we don't normally just use numbers like that because it's difficult to do math with those kind of numbers. Instead, they've used a number space where shader color is 0 to 1. So red is 255.00 in that 255 range, but in a shader, we usually use 0 to 1.0. 0 would be black, and 1 in this case makes it red when it's put in the red channel, right? All right, so that's something that's important to note about working with shaders. Let's talk about variable usage. Now, I'm introducing these things because this is kind of a foundation of shaders, because we're going to go into more complex and more in-depth information as we go through the lessons in the future here. Shaders have different ways you describe this information, and this part is a little bit confusing, and it's because shaders are used on all kinds of devices. On phones, especially older phones, it was critical to keep the amount of memory variables were stored in as small as possible. And so they used a prefix called, or I guess this is a cast or a type. There was a fixed, a half, and a float. If you go and look at shaders that are generated, you'll see these names. See, there's a float 4, float 2. There's a fixed 4. In the Surface shader, you don't see them as much because a lot of it's hidden. But there's a float 2. There's a half, fixed 4. So when you see those, just know those are declaring variables. And what those are is different capacities. You'll notice that sometimes there might be a half or a half 2 or a half 3. Basically what that is you're making a variable that can store different amounts of data. So just if you see a word like half, you can know it's just one number. If you see a half 2, you see 2 numbers. Half 3s are 3 numbers, half 4s are 4 numbers. And that oftentimes corresponds to ways that you get at those variables. So a half by itself, or a fixed or float, is just the variable. But if you want to get into 2, 3, and 4 variables, usually you address them with a 2 with x, y, with fixed half 3s and float 3s. You might use a color that's XYZ or RGB. Those two terms are interchangeable. And with the 4, it's XYZW, RGBA. Let me see if I can see an example of that in here. This is, I don't see a perfect example of this, but this is implied with this one here, because what's happening is I'm reading a texture and it doesn't have any variables, so it's assuming that all 4 colors, R, G, B, and A, are going to get written into this. I could just as easily say RGBA, and that would do the exact same thing. I also could do XYZW, and that would do the same thing. That's going to be a little bit confusing at first when you're first learning shaders, but that's a very important key to understanding. Now, something that might throw you in, and honestly, I've been making shaders for a long time. I still sometimes struggle with this fixed, half, and float. Let's go look at the websites for this. Let me see if I can find. I looked these up. If you look at the way I found this document, this is Unity. Now, here's something important to understand about Unity documentation. Always pay attention to which version you're looking at, because occasionally you'll look up something and it'll say, hey, this was valid in Unity version 3. And so I always try to use the latest documentation. Everything I'm showing you today is using Unity 5.5. But if I go in here and I look up what is that half, fixed, and float mean, we can read about this at this location. The way I found this, I said, what is difference between float, half, and fixed? And I went and found somebody's reference on this, and then somebody had a link to this, and then boom, there I was. But let's just kind of touch on the highlights. It says, when writing shaders in CG and HLSL, there are 3 basic number types: float, half, and fixed. For good performance, always use the lowest precision that is possible. This is especially important on mobile platforms like iOS and Android. Good rules of thumb are, for world space positions and texture coordinates, use a float precision. For everything else, including colors and so forth, use a half precision. And for very simple operations on texture data, use a fixed precision. They will tell you down here a little later that the fixed and half precisions, at least on more modern hardware, are interchangeable and they run exactly the same. For example, it says fixed precision is generally only useful for older model CPUs or GPUs. Most modern GPUs, the ones that can run OpenGL ES3 or Metal, internally treat fixed and half precisions exactly the same. So you're going to see probably in the going future that these terms may eventually fade away, but for now, just know that's what they are. And oftentimes you'll see float, fixed, and half interchanged. I try to keep them all the same, but this is what the shader dumped out from just saying, make it for me. All right, let's go back to the lesson plan here. So let's talk a little bit about structures. You're going to see in your shaders things called structures. If you're familiar with programming language like C, structures make perfect sense how they work. There is a slight modification that you may not be familiar with, and that is this colon and then these terms after this. These terms after this are what's called a semantic. And let's go look at the actual shader. Every shader will look like this to some extent. In the surface shaders, this stuff kind of gets hidden and it looks simpler. But over here in the vertex fragment program, you'll see these semantics more prevalent. What a semantic essentially does, it says this is the intent of what this variable is going to do. For example, in this top structure, this is what is fed into the shader from the raw vertex data from the model. So I'm getting a position and I'm getting the UVs. That should sound very familiar to anybody that's worked in 3D. This is the object space information. You notice it's missing over here, and that's because surface shaders hide. This is happening somewhere under the hood of the shader, but you don't see it in the surface shader. In the fragment vertex program, again, you're closer to the metal of what's going on, so you're going to see these little more raw components exposed as you're using those. But you can see this is the vertex information that's coming in, and I can define other things that make sense, but for now I'm going to keep this simple. So we're passing in the vertex position in the UVs, and then the vertex program is processing this position information and it's feeding it back out to what's called the fragment program. And I'm processing this thing, so I'm computing where the UVs are going to get interpolated at. And interpolation is a fancy term. If you think about a polygon, let me see if I can draw this fairly quickly. Let's just make a quick little diagram what happens inside of a shader. All right. When you have a polygon that looks like this, remember, you've got vertices, right? Well, a vertice might have, it has obviously a position somewhere in space, but it might have for UVs. Let's say this UV location was at 0. Let's get this down to a little more manageable size. This might be at 0, 0 over here, and this might be 1, 0. And this might be 1, 1. Well, what happens in a shader is the vertex program is saying, hey, this is where these vertices are in 3D space, and I'm also going to tell you where the UVs were at their vertex position. Now, the fragment program, on the other hand, is going to say, hey, I got the vertex positions, but I need to interpolate. In other words, I need to calculate the positions for all the positions between these vertices to figure out where the proper UV space is for those pieces, okay? And I believe the same thing would happen with, defining this triangle, so the edges and where all that gets defined. Okay, so that's a layman version of what's going on inside of a shader. All right, so let's go back to our lesson here. Get rid of my fancy drawing here. All right, well that's kind of the end of this first lesson. This is laying some groundwork. Like I said, I set out to initially do that car shader, and I realized there's so many concepts here that need to be at least kind of understood before I should type in the shader. And so I'm sitting there typing, and I was thinking, nobody knows what a half 3 might be, or nobody knows what, the color space, how that works, or any of that. So I felt it's important to kind of start with this basis, and I'll probably do a couple more build-ups on those shaders. It's kind of a closing thing. I wanted to kind of give you a taste of working with shaders and how this is effective. And then we'll be done. Okay. Let's go look at this cube here where I colorize this. The nice thing about shaders are you can do a lot of great things inside them. I'm going to go to the right program. Let's start with the fragment program. You can actually go in here and type in your color that you want to. Now this is obviously just for a demonstration. I can say half 4, and let's say I want to make this a shade of blue. Okay, so what I did is I let the shader come in and define a color, but then I overrode it at the end. So if I come back in to this guy, of course that had to act up on me. What did it do? One thing, I had an error that came in here. This is supposed to be a half 3. There it goes. So it's funny, in Unity 5.5, everything used to go pink when there was an error. Now I'm noticing it won't go pink every time. And so if you don't pay attention to your error messages, you may not get it. So that's how that goes. And you notice even though I send out a perfect color blue, it's still shaded. That's the surface shader doing its magic. Let's do the same thing in the vertex fragment program. In this case, it's a little more it's a little different. So in this case, I've got to define this variable up here that says cull. That's actually pulling from the texture, but let's override it again. Let's make this one a shade of green. And this one is a 4 because you can see the output of the shader needs to be a fixed 4 versus this one. There was no output. And that's because in this one, the shader content was passed in and out of this structure. We're going to talk about that in the next lesson, what those work like. But in this case, half 4, let's make this green. Notice that 4th value is my alpha. I could do that to anything. This shader isn't set up to do alpha, so no matter what I put in there, it'll come out the same. But let's look and see what we got. Boom, there's green. Okay, so we're gonna get into this a little more in depth over the next few lessons, and then what I'd like to do is then switch over to just talking about shaders in general and give examples like that car shader. I'd love to break that down and explain how that works, but I feel like this foundation work is critical for you to understand. So I hope you enjoyed this lesson. If you have any questions, again, feel free to contact me. I'd love to talk about shaders. This is my website at Extra Cheesy Games. You can go check out the game I'm working on called Humans Must Eat. And there's my email if you have any questions. Thanks for watching.